today we're going to continue discussing our basic integration rules or formulas. So we start with this first formula, although we were able to discuss this already. So we have the integral of the constant k times f of x dx is simply equal to k. So you isolate k times the integral of fx dx. So this means that if we are going to find the integral of a constant times any function, so all we have to do um, is to simply isolate k outside the integral symbol, then get the integral of f of x dx. Next one is the integral of the sum and difference of two functions. So this is simply equal to, if we are given this type of function of this form, or sum of two functions f of x and g of x, or difference of f of x and g of x, so we just simply write the integral of each function. If it is sum, so plus the integral of the second function. If it is difference, then we're going to find the integral of f of x dx minus the integral of g of x dx. Now, if you're given n functions, for example, meaning there are many functions, not just two, not just three, but many functions, all we have to do is just to simply follow this formula. So we just simply add plus um, another function plus another function if it's uh, we have many functions already. So to apply these rules, we have this example. So how about this expression? If we are asked to find the antiderivative or the integral of 5x cubed plus x squared minus 6x plus 4. So all we have to do is to apply the um, integral of the sum or difference is simply the sum or the difference of integrals. So this is equal to, so you just get the integral of each term. So integral of 5x cubed dx plus the integral of x squared dx minus the integral of 6x dx plus the integral of 4 dx. Now, this is equal to, so 5 is constant, so you write outside the integral symbol. Then you get the integral of x cubed dx plus integral of x squared dx. And again, 6 is a constant. So we just simply write here outside the integral x dx plus the integral of 4 dx. Actually, we can also write this 4 outside the integral symbol. Now, so we are now ready to find the integral of this. How to get the integral by using the first formula? We just simply add the exponent, then you copy the exponent in the denominator. So this is x raised to 4 over 4 plus c. So since you are asked to find the integral or the antiderivative of each term, so we just simply add also c to each term. Okay, this one. And the integral of this is x cubed over 3 plus c minus the integral of x is x squared over 2 plus c plus the integral of 4 dx is 4x plus c. Simplifying this whole expression, we have 5x raised to 4. And maybe you just ask, Ma'am, where is C? The first C, the second C, and the third C. Since C or simply C1, for example, C2, C3, and C4, these are just constants. So we can treat this as one constant only. So, for example, this is C1, C2, C3, and C4. So we can write that one into 1c only. So that's why simplifying the whole expression, we have 5x raised to 4 over 4 plus x cubed over 3 minus 3x squared plus 4x plus c, where c is simply equal to c1 plus c2 plus c3 plus c4. Okay, so what is the integral of this, or the antiderivative? This one. Next example, the antiderivative or the integral of 4 sine x minus 3 cosine x dx. So applying the basic integration formulas for trigonometric functions, and also the integral of the difference of two functions, right? So this is simply equal to 4 times the integral of sine x dx minus 3 times the integral of cosine x dx. We know this already, that the integral of sine x dx is negative 4x. So that's why we multiply negative 4 cosine x by the negative cosine x, I mean. Negative cosine x times 4 is negative 4 cosine x plus c. The integral of cosine x is sine x. That's why we have negative 3 sine x plus c. And since we have plus c in this term, so we also have plus c in this term. So we have negative 4 cosine x minus 3 sine x plus c. This c here is the new c, which is equal to c1 plus c2, for example, or the c in this expression and the c in this expression. Okay, now another example. If we are asked to find the integral of quantity 3 minus x squared raised to 2 dx, how can we find the integral of this expression? So it is easy to get the integral if we are going to expand this expression. That is, the expansion of this expression is equal to 9 minus 6x squared plus x raised to 4. And applying the integral of the sum and difference, so this is simply equal to, what is the integral? The integral of 9 dx minus the integral of 6x squared dx plus the integral of x raised to 4, which is equal to 9x minus 2x raised to 3, because we simply add 1 to the exponent 2. So this simply equal to 2x cubed over what? Um, 2x cubed, I mean. Because from here, 6x cubed over 3, so 6 divided by 3 is equal to 2. Now, the integral of x raised to 4 is x raised to 5 over 5 plus c. Okay? So, the final answer is x raised to 5. If we write this one in descending order, we have x raised to 5 over 5 minus 2x cubed plus 9x plus c. Another example, we have integral of sine x over cosine squared x dx. How can we solve this one? We can solve that one by simplifying the expression. Now, we have to take note that sine x over cosine squared x can be written as 1 over cosine x times sine x over cosine x, right? Because if we're going to multiply this one, this is equal to cosine squared x. So, this becomes, now take note that 1, okay, 1 over cosine x using trigonometric identity is just equal to secant x, and sine x over cosine x is just equal to tangent x dx, right? And we already have the formula for the integral of secant x tangent x dx. What's the formula? Or what's the answer? It is secant x plus c. So the integral of this expression is simply equal to secant x plus c. And again, just like finding the derivative of trigonometric functions, all we have to do is to familiarize some of the trigonometric identities that can be used in order to simplify the expression to come up with a correct answer. Okay, so those are some examples of applying the basic trigonometric formulas or basic um, formulas for integration. So thank you so much and hope you like this video. Just keep on sharing the learning that you've got from this video. Thank you and God bless.